Go for it. Okay. It's like I said at the end of the first semester, too. Okay? And this time I have it written down. It's like I said at the end of the first semester. There are so many different topics that we go over in this class that it's very easy to lose sight of the fact that it's all connected in some way. All of it is tied together. Okay? And even that first semester stuff you've seen come back. So what did we go over this semester? First we started with charged particles. Charged particles, we noticed when we brought them together there was a force. There was a force, but they weren't touching. So all of a sudden we didn't have a contact force, we had a field. Now if we had a field, we could define a field based on the force and the charge of the particle. After we said that, all of a sudden we go hit upon Gauss's law and we say, hey, if I circle a particle, I can determine by the field how much charge is enclosed, or vice versa. I can go the other way. Then all of a sudden we said, hey, if I have a particle sitting in a field and I want to move it in a field, that takes some energy. If it takes some energy, all of a sudden I can define potential again. So we define potential, we're talking about voltage. Now we say to ourselves, hey, I can store voltage per charge. And all of a sudden we have the idea of capacitance. We have capacitance, we have stored charge, we can start to store charge and then move it later. We have the idea of circuits. So now all of a sudden we have DC circuits. We have capacitors, we have resistors. That gives us Kirchhoff's laws, Ohm's laws, the junction rule, the loop rule, and Ohm's law. So all of a sudden we have charges moving, but then all of a sudden we have this current moving through a wire, and if you have a charged particle moving in the vicinity of a wire, all of a sudden the charged particle starts to bend. And all of a sudden if you have a magnet or a compass in the area of a wire that has current moving through it, it deflects, and you say to yourself, whoa, what's going on here? So all of a sudden we start to see that magnetism is active where current is active. We'll get back to that later. But all of a sudden you have force on charged particles in a magnetic field. Force is equal to QV cross B. And then also you say to yourself, well, two wires that are lying each other parallel. All of a sudden, if you have the right currents, they stick together, they're far apart. What happens? This force equals IL cross B. And so all of a sudden from there, you get Ampere's law. And you recognize that the B field is related to the current. And from Ampere's law, then all of a sudden we say, hey, if we have a circle of wire and I put a magnet back and forth in and out, all of a sudden I change the magnetic flux. But when I change the magnetic flux, I get voltage. If I get a voltage, that means that magnetism and electricity are connected together. What is that? Then we got Faraday's law. That's fantastic. So all of a sudden we can build solenoids. Solenoids are inductors. And if I move that magnet back and forth, all of a sudden I have a voltage. It changes and changes and changes. Well, guess what? Now we have alternating current. After we have alternating current, we can do AC circuits. I know you hate those. But then all of a sudden, the physical reality of an alternating current circuit allowed us to look at a very real way of doing imaginary numbers. So you have parts of current that disappear and then they reappear. And it all happens with a cycle. And of course you can maximize, you can alter the elements, the capacitors and the inductors, to give you the maximum output of voltage and current in a circuit. And now, all of a sudden, you have E fields and B fields, and they're tied together. And when you have these tied together oscillating, what do you get? You get light and electromagnetic radiation and everything in the world that you see. And everything that we've been talking about in these past 2 weeks. But even though that was this semester, think about last semester. It still came back. You had torque. You had forces, F equals ma. You had circular motion, cyclotronic motion, right? mv squared over r all of a sudden. You had potential energy, kinetic energy. It was all there, all the time. And so I hope you realize that all these things that we did in the first semester, they don't exist in a vacuum. All these things are connected. And it's really easy to lose the connection of the things if you're just treating it like a subject and like a thing to be learned and a thing to be memorized. And it's easy to lose sight of it, especially when you're in college and you're saying to yourself, I got to do this class, I got to do this, I got to do this homework, I got to do this thing, and then I have to learn that thing next. It's very easy to lose the bigger picture. I know that. Okay. But if there's one thing overarching that I hope that I have taught you, two things. Common sense, physics, math. It's the first and most important thing. Okay? The world is beautiful and it's mysterious, but it's ultimately known. And no matter what it is you want to understand and learn about, no matter how mysterious it is, and even if we don't have an answer right now, it can be found. And how do you find it? This is the second thing I hope I've taught you. And I hope I haven't taught you this just for physics. Because I have come in here over the past year and I have had my share of difficulties. And every time I reach a problem, either in here or in the real world, what do? I look at the problem. I look at the data I've got. I think about my experiences and possible solutions. I try one. I see if the outcome jives with reality. You'll be solving your final exam questions like that. But I hope you realize that beyond this class goes far beyond it. And I hope that what you learn here, you carry with you always. Nothing would make me happier than that. And I hope I've taught you something beyond physics this year. And then before we go, I do want to also thank you, because I mean it when I say that everyone in here, teaching for 9 years, I have never met a student who didn't have ability, who didn't have potential, who didn't have talent. And you all have that. 9 years teaching, I never met a student who wasn't important. Now, thank you for everything that you did. As far as this class is concerned, I mean, I will always be there for you. You can always get in touch with me. Please do. As far as this class is concerned, I don't want to go. But it's time. Thank you for being a wonderful class.